All right, another video on linear relations. This one is on perpendicular lines. You must be excited. All right, so when we talk about perpendicular lines, what we've learned in the past is that this means the lines cross at a right angle or a 90-degree angle. And that's all well and good, but in this course, what we need to know is that perpendicular lines are related by their slopes. Now, just like parallel lines, those slopes have a relationship, but unlike parallel lines, their slopes aren't the same. Now, remember, parallel lines cross through the graph at the same steepness or the same slope. They ran side by side and never touched. Perpendicular lines are different. Their slopes are related by something called negative reciprocals. Now, negative reciprocals are two big nerdy words to explain a pretty simple concept. Here's how their slopes are related. If you have the slope of one of the lines, you've got to take that slope and make sure it's in fraction form. If it's not in fraction form, whatever the number is, you can put it over +1 to turn it into a fraction. So don't worry if you're given a slope that's not a fraction, just put it over 1 and then follow these steps. All you got to do once that slope that you're given is in fraction form, if it wasn't already, you flip that fraction, meaning the top number goes down to the bottom and the bottom number comes up to the top. And once you've flipped the fraction, you change the sign of that fraction. Changing the sign means that if the original fraction was negative, it comes out positive in the end. But if that original value was positive, then you've got a negative once you do the negative reciprocal. So changing the sign means changing the original value from positive to negative or from negative to positive. Now, for some reason, it can be a little bit confusing identifying a negative fraction to begin with. So if you're given a fraction and the negative sign is either out front, up on the top number, or down with the bottom number, then you've got a negative value for that fraction. So as long as there's only one negative sign, doesn't matter where it is, out front, up top, on bottom, that's a negative fraction. Now be careful, it's possible, although rare, that you might have a negative value on top and on bottom of your fraction. If you see two negatives in a fraction, one on top and one on bottom, that actually represents a positive value. Remember, a fraction represents division, and when you have a negative number divided by another negative number, the result is always positive. Now, keeping in mind that slope is the a value in y equals ax plus b, see if you can follow along as I show you how to find the slope of a line that's perpendicular to the one represented by the equation on the screen. Now notice when I start out here, I wasn't given the proper format for this equation. It wasn't in y equals ax plus b form. So I have a little bit of work to do here before I can actually get started. And now that the equation's in the proper format, all I have to do to find the slope of a line that's perpendicular to this one is grab that a value, turn it into a fraction, and find the negative reciprocal. So first up, I'm going to take that a value and put it over 1 to turn it into a fraction. And remember, no matter what number I'm turning into a fraction, I always put it over +1. Doesn't matter if the number up top is starting out negative. To make anything a fraction, it's over +1. Now all I'm going to do is flip that fraction, so the bottom number is coming up top and that top number is going on the bottom, and I'm going to change the sign. Now my original fraction was negative, so watch how the answer is positive here. And that's what we mean when we say change the sign. This was starting out as a negative, so it's got to be positive in my answer for negative reciprocal. If it was starting out positive, it would be coming negative in the negative reciprocal. Now that you get the idea of what negative reciprocals are in perpendicular lines, watch these couple of examples on how they might ask this on an exam.